اوكي ماشي. term 1 week 3 math CA. This week is a bit harder. I'm gonna finish all the easy questions. بعدين we'll like 5, 6, 7 Pascal's triangle 9 let me write these down. One sec. 5, 6, 7, 9 infinite sum containing xk 12 okay 13 14 and 15. Let me see 16 and 17. Okay, 17 and so on. So we're gonna solve 1, 2, 3. Okay. How about this? Okay, we're gonna solve the easy ones first, and then I'll explain the tough topic. Okay, the new one. So let's start. Okay, the easy ones. Sigma I squared. Okay, you know sigma I squared until 5, and you're gonna start with 1. So 1 squared plus goes to 2 squared plus 3 squared plus 4 squared plus 5 squared. We finish at 5. Okay. Question 2. Okay, if sigma c is 20, what is 10? Sigma 10 c. Okay, that's just 10 times 20, so 200. Yani, these are easy. What's the value of sigma 2 100 times? So it's just 2 plus 2 plus 200 times. So you could just do 2 times 100, 200. You have sigma p is 25, sigma q is 30, sigma r is 10. What's sigma p plus q minus r? P plus q is 25 plus 30 minus r is 10. You get 55 minus that, yeah, 45. هلا 5 6 7. These are the hard ones. بعدين let me continue. We said do 8 10 11 16. 8 10 11 16. Okay, for question 8, let me fix my mic. You distribute the I, right? So it becomes sigma I squared as the 2I squared plus I, okay, up until 4. Oh my god, what is this handwriting? Sigma up until 4. Okay, so you split this up into sigma, sigma 2I squared plus sigma I up until 4. Take the 2 out, sigma I squared plus sigma I up until 4. If you remember this, the rule for sigma I squared is that it's n plus 1, 2n plus 1 over 6. So it's going to be 4, 5, 11 over 6 is going to be 4, 5, 2. Hold up. Yeah, not 11. That's the 9. 2 times 4, 8, 8 plus 1, 9. Okay, plus sigma I, you have this 2 outside, huh? Plus sigma I will be n plus 1 over 2. So it's going to be 4, 5 over 2. 2, this becomes 2. Okay, you get here, you cancel this with this, comes 3 down, 2 up. This with this becomes 3. 6 times 5, 2 times 3, 6, 6 times 5, 30, 30 times 2, 60. 30 times 2, 60. Plus 2 times 5 is 10, so 70. Okay, هلا question 8, 10 and 11. I can do 10 and 11. 10. Okay. Ooh, 10 كمان. I can't do 10. 10 also later. 10 is later. Let me see 11. Okay, we can do this. Okay, given that sigma k is n plus 1 over 2, sigma k squared is n plus 1, 2n plus 1 over 6. So here they give the rules. What number is equal to this? Okay, this is equal to sigma 2k squared, separate them, minus sigma 3k plus sigma 2 up until 20, 20, 20, صح? Take the 2 out, 2 sigma k squared, minus, take the 3 out, sigma k, plus sigma 2, 20, 20, 20. Okay, sigma k squared, they have the rule here, so it's 20, 21, 41 over 6. Divide this and this, you get 10. 3, divide this and this, you get 7. Up here, 10 times, oh, that's a big number. 10 times 7 times 41, 2870. So 2 times 2870 minus 3 times sigma k. Sigma k is 20, 21 over 2. Because n plus 1 over 2, huh? So 20 plus 21 over 20 into 20 plus 1 over 2, which is 21. Okay, this 10 times 21, 210, 210, so 3 times 210, plus sigma 2 20 times is 2 times 20, so 40. Ooh. Okay, if you actually solve this and do 2 times 2870 plus, as the minus 3 times, minus 3 times 210 plus 40, you get, I think I broke my chair. No, okay, it's good. 5150. Okay, yeah. هلا question 16. Skibidi toilet. You see, لا 16, yeah, 16. Okay. Here, the sigma again, we distribute the I. Like I told you, if there's a number outside, I keep it outside. Okay, so it's gonna become sigma 2 I squared plus I up until 6. بتطلع ال 2 لبرا. Sigma I squared plus I بتصير 2 sigma I squared plus sigma I. Okay, انتبهوا, here the 2 is distributed the whole thing because the 2 is already part of the whole thing. But in the other one where it was sigma 2i plus 1 and you distribute the I, the 2 was only part of this one here. Okay, that was in a different question. Some people asked me about this in school. I think it was Ziad Turkey. He asked me, he's like, Walid, why here do you distribute this, blah, 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 here you don't? Just pay attention, some people can get it wrong. It's a common mistake, yani. Anyway, up until 6, you know, sigma I squared is n plus 1, 2n plus 1 over 6. Sigma I is n plus 1, 2. So yeah, you're gonna get 2 6 plus 1, 2 times 6 with 12 plus 1 over 6 with 6, plus, you know, sigma I n plus 1 over 2, so 6, 7 over 2, pew pew, 3 times 7. You're gonna get here 7, this is 7, this is 13, 7 times 13 is 91, plus 3 times 7, 21, 2 outside, you're gonna get 120, so 224. 224. Okay. هلا خلصنا easy questions. Okay. I'm gonna explain now the new stuff. Okay. Binomial theorem. A plus B to the power of n. I'm gonna split this up into 2 segments. Okay. 5, 6, and 7 follow a different rule. Okay. So it's also binomial theorem, but in a different way. Okay. A plus B to the power of n is sigma. Okay. K equals 0, n c k, a to the power of n minus k, b to the power of k. Walid, what the sigma did you just write? Okay, listen, I'm gonna, okay, it might look complicated, but I'm gonna help you understand. Okay, let's say it was a plus b to the power of 5. Okay, it's gonna be sigma k equals 0 up until my n is 5, right? Up until 5, n k a to the power of n minus k b to the power of k. In this case, my n is 5, right? So let me make this a bit smaller. My n is 5. Okay, so I can solve a bit easier now. How does this go? It's a sigma. So you start k equals 0, then k equals 1, then k equals 2, then k equals 3, then k equals 4, then k equals 5. Okay, we start at 0, then we reach 5. So how does this look? Let's start at when k equals 0. We start 5, c0, right? Remember, this is the combinations. You know, in the calculator, remember we did combinations? It was n factorial over r factorial, n minus r factorial. See, since calculators will be allowed for this AMS, عادي, you can do it on a calculator. Okay, so ما تعتل هم, don't worry about that. Okay, so we start at 0. It's going to be a to the power of 5 minus 0. In this case, my k is 0. 5 minus k, 5 minus 0, 5. And then b to the power of k, b to the power of 0 is just 1. You know, you don't write anything. To the power of 0 is equal to 1, so you don't write it. هلا becomes 1, right? So a to the power of 5 minus 1, 4. b to the power of 1, right? Plus, هلا it's 2. 5c2. a to the power of 5 minus 2, 3. b to the power of 2. Plus, هلا it became 3. a to the power of 5 minus 3, 2. b to the power of 3. Plus, هلا صارت 4. a to the power of 5 minus 4, 1. b to the power of 4. هلا صارت 5. This is our last one. 5 minus 5 is a to the power of 0, so we don't write it. And then b to the power of 5. Here are some nice tricks, okay, that you can see. If you look at our first term and our last term, you can see that it has no coefficient. Okay, there's no AB. It's just b to the power of 5. It's always a to the power of n, and then b to the power of n as your first and last terms. Okay, what else can you realize? The sum of powers always equals n. Okay, so if you know this one, you can immediately know this one here. Okay, so you can kind of get the hang of it. On a calculator, you can just go like, هلا, you need to find these combinations, right? So you take out your calculator, okay, and we start 5c0. It's 1. So you go back, like, it's 1, a to the power of 5. We don't write that one. 5c1 is going to be 5, a to the power of 4b, right? Plus 5c2, go to your calculator. It's going to be 10. So 10, a cube, b squared. Plus 5c3, I think it's going to be 16. I'm not sure. Or 15. I think 15 actually. 5c3. Oh, it's 10 again. 5, 10, 10, 5. Oh, yeah, 10. So 10, a to the 4. Sorry, a to the 2, b to the 3. Plus 5c4, it's going to be 5 again. Remember when two combinations, remember if this number plus this number adds up to the top number, then they're equal to each other. So we know 5c1 is 5. So 5c4 will also be 5 because 4 plus 1 equals 5. Okay, that was from last week's AMS. So 5ab to the 4 plus 5, 5, which is 1. 5, 5 is 1. So you write b to the power of 5. This is how it would look fully expanded. Some nice things to note is that 5, 5, 10, 10. You always go backwards. So this is how you find the coefficients. You can use a calculator. Okay, another way, okay, actually no, before I move to Pascal's triangle, I want to mention more things here. You start counting at 0, okay? Some questions will ask, what is the third term? Okay, and what will some students do? They go, oh, third term, yani k equals 3, so it's going to be this one here. So it's going to be, in this case, this one. If you write this in your exam, your paper will get spit on, okay? The third term, count. This is your first term. This is your second term. This is your third term. So remember, we start counting from k equals 0, not k equals 1. So if they say fourth term, you're going to look at your third, whatever, value, okay? That's one first thing to note. Another thing to note is the constant term. Okay, you know, when they ask for constant, actually, no, constant term, that's when we get it in the question. Sometimes they're gonna ask the questions like this. Let's say 2x plus 1 over 2x, مثلا, like this, and they put it to the power of, let's say, 13. Okay, they say, what is the coefficient? Okay, you know, coefficient is the number beside the letters. Okay, coefficient of the x, let's say, of the x term. Okay, of the x term. Okay, let's see here. What do you mean by the x term? معناتها in my answer, I'm gonna have x. Okay, we know that when you expand, you're gonna get this times this to the power of something times this to the power of something, right? Like over here, you see it's this, like it's a times b, a to the 4 times b. So if you were using this rule, it would be like مثلا 2x to the power of 4 times 1 over 2x. If you realize, okay, forget about this now, 13, forget about 13. Let's go back here. If you realize x to the power of 4 divided by x, you know that x to the n over x to the m from grade 8 is equal to the x to the power of n minus m, right? So if I had x to the power of 4 divided by x, it's going to be equal to x cubed, right? So here, x to the power of 4 divided by this x here gets me x cubed in my answer. And this, whatever, 2 to the power of 4 divided by, okay, I don't care about that. So what I'm talking about here is the x part. So let's say they want in my answer x, okay? Let's look here. Don't I have something x is divided by other x's? So I have to see what power here and what power here. You know, I have to somehow get x in my answer. And since we're dividing, we know that they're gonna, when you subtract, we're gonna subtract the powers, right? So let's say, مثلا, I got 5 here and 8 here. 5 minus 8, is that 1? You know, x, yani, it's power 1. Is 5 minus 8 1? No. So my numbers will not be 5 and 8. So I need two numbers. We said they always have to add up to your n, right? Like look here, 4 plus 1, 4 plus 1 is equal to 5. 3 plus 2 equal to 5. 2 plus 3, 5. 1 plus 4, 5. Okay? We know that they always have to add up to your n. In this case, I need two numbers, right? The two powers, they will always add up to 13. So let's call the two powers k plus, I don't know, k plus, let's just say x. Okay? K plus x, we know they add up to 13. But we know that when you subtract these two numbers, x minus, let's call x the power here, x minus k, I'm going to get what? 1. So which two numbers, when you add them, you get 13, but when you subtract them, you get 1? 7 and 6. Okay. طب Walid, we know it's going to be 13 ck, right? 2x to the power of whatever. We know it's n minus k, so 13 minus k. Remember the rule, it's over here, a to the power of n minus k, so 13 minus k, right? Times 1 over 2x to the power of, what's b to the power of? K. Now we know what the numbers are, 7 and 6, right? Okay, so which one is going to be 7, which one is going to be 6? Okay, the bigger one will be 7. So which one's going to be 6? The smaller one. So k is going to be 6. So 1 over 2x to the power of 6. This is going to be 2x to the power of 13 minus 6, which is 7, صح? So 2x to the power of 7. And we know that our k value is 6. So it's going to be 13c6. And you're going to, whatever, you're going to find out what 13c6 is and just solve this. Okay? But, not but, actually. So in general, whenever you're solving these types of questions, you're going to see now, you need to figure out one objective. What does k equal? Okay, this is your main part. The k. Okay, the k part, that's what you have to know. Okay, when you find out what k is, everything becomes easy. Okay, we need our k value. Okay, let's move on to Pascal's triangle. Pascal's triangle is to find out what these coefficients are before, without like having to do it on a calculator. Okay, this is how Pascal's triangle looks. You have a triangle, it's like a pyramid. You have 1, you have 1 1. Okay, as you go down, you're gonna add the numbers beside each other. It's like it starts with 1 at the top, but you can't like add 1 with anything else, so you get 1 1. Okay, on the sides, you're always gonna put 1 and 1 again. Okay, you always add 1 on the sides. Okay, and then put a number in the middle. What's the number in the middle gonna be? Actually, not instead of memorizing that you put 1 on the sides, let me tell you this. You're gonna add this number here with the number on its left. There's no number, so you get 1. You're gonna add this number here with the number on its right. There's no number, so 1 plus 0, 1. Okay, again here. This number with the number on its left, there's no number, so you get 1. This number with the number on its right, there is a number, 1, right? So you get 1 plus 1, 2. Then this number here with the number on its left, we already added them with each other, so we skip that. Now with this one with the number on its right, there's no number beside it, 1 plus 0, 1. Okay, هلا 1 plus the number on its left, 1. 1 plus the number on its right, 3. 2 plus the number on its left, we already added them together, so let's see 2 plus the number on its right, 3 again. Okay, let's go to this one now, we're done from the 2. 1 plus the number on its left, we already added them together, so we put 1 plus the number on the right. If you realize, as you're going down, you have 1 on the sides every single time, right? So you can make it a bit quicker and just put 1, 1 from the start. Okay, then you put 1 plus 3, 4. Okay, we're done with these two. 3 plus 3, 6. We're done with these two. 3 plus 1, 4. 1, 1. 4 plus 1, 5. 4 plus 6, 10. We're done with 6 and these 6 and 4. Now we go to here. 6 plus 4 again, 10. 4 plus 1, 5. 1, 1. And it goes so on and so forth. I'll do this last one now. 5 plus 1, 6. 5 plus 10, 15. We finish these two from these two together. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. So if you realize, it goes 1, 5, 10, 10, 5, 1. 1, 4, 6, 4, 1. Okay, so it goes like backwards, you know what I mean? 1, 6, 15, 20, 15, 6, again, 1. Okay, so this is like the order of the coefficients. So let's say, مثلا, for this example, a plus b to the power of 5. Okay, power of 5, yani we're working with 5. Okay, the first one always, the coefficient, it doesn't have coefficient, it has 1. So you take this one, done. Then the second term, its coefficient is 5. Let's see, in Pascal's triangle, is it 5? Yes. So you put the 5. Okay, then the third term, 10. Do I have 10? Yes, I do. Okay, and then this 10, 10, 5, 5, 1, 1. So as you can see, you can also use Pascal's triangle to figure out the coefficients immediately. So like what I'm trying to tell you is like, مثلا in the exam, if they give you a plus b to the power of 6, like next week in the periodic, I would advise you to, as soon as you come inside the exam hall, come early, go early, take your scratch paper, quickly draw Pascal's triangle. Okay, so like مثلا when you get this, you'd immediately know that my coefficients are going to be a to the power of 6. It's always, the first one is this, right? It's always to the power of your n. Okay, plus the second one, coefficient is 6. So 6, whatever, a, 5, b. What's my second coefficient? 15. A4, B2. You can be very quick with it. Remember that, just know that they add up to 6, right? And you keep on decreasing the power. It was 4, now it's going to become A3. And if this is 3, it has to add up to 6. So what do I add? B3. What's the coefficient? 20. Then next, what's my next coefficient? 15. This decreases by 1. It's always decreasing by 1. A squared. What does this become? B to the 4. Realize, this decreases by 1. This increases by 1. It steals it from here. Okay, plus what comes after 15? 6. 6a now decreased by 1, becomes a to the power 1, b to the power 5. Plus the last coefficient is 1, so you just write b to the power of 6. You see how easy and fast this became? That's how Pascal's triangle can help you. Okay. Okay. Knowing this, we're going to skip 5, 6, 7. We're going to do 9. Okay, no Pascal's triangle. Okay, let's see. They want what's the value of d. Okay, let's add them up. Okay, a, what's a here? Let's start from the top. 1, 1 plus 1, we got the 2. 2 plus 1, so we're going to get 3 here. Okay, and then 2 plus 1, 3. Okay, then 1, we got the 1. 1 plus 3, 4. Okay, 3 plus 3, 6, right? Okay, we're done with the 6. We got it. Okay, we go down. The rest is filled out. 1, they got the 5 by doing 4 plus 1. Now 4 plus 6, so we're going to get 10. And then 6 plus 4 here, 10 as well. Okay, then they want the d, so they got the 1, they got the 6 by doing 1 plus 5. Now what's beside here? 5 plus 10, right? 5 plus 10, so you're gonna get 15. Okay, if they wanted e, it would be 10 plus 10, which is 20. Okay, هلا question 10. Okay, نحن did we do 11? Apply the rules for, yeah, we did 11. Okay, what's this? What is the coefficient? Okay, yeah, 10 as well is part of the hard ones. So 5, 6, 7, and 10, I'm gonna leave them until the end. Okay, not hard, but they follow a different rule. Actually, do they? Yeah, okay, it kind of does. Yeah, I'm gonna give you the rule later. It just makes all these expanding thing way easier. Okay, after 10, I have written 12. Let's do 12. Okay, what is the coefficient of the x5 term? See, they won't ask you to expand it all, they just want a certain term. Okay, the x5 term. Here, do I have two x's? No, so there's no dividing, so you don't have to see which two numbers add up to this and then subtract. You don't have to do that, there's only one x. So, I know I'm gonna have x to the power 5 in my answer. So what is gonna be the power of this here? X to the power of 5, right? So, since my n is 7, what will this have to be? The minus 1 over 4. What does it, remember if there's a, look, be careful now. If there's a minus, you have to put it here. If this is power 5, what does this power have to be to get me 7? Okay, 2, right? If you want an easier way to do it, whenever you're faced with these questions, write down the general term. Okay, the general term. The general term of the binomial expansion, okay, this is the easiest way that I found, okay, while solving, is the general term we know is nk, a to the power of n minus k, b to the power of k, right? And we can just substitute. We know our n is 7, right? So 7k, a to the power of 7 minus k, b to the power of k. Hala, you can just see what do you have in the question. They want x to the power of 5, right? So this here, let's just replace the a and b by 2x and minus 1 over 4. 7k, 2x to the power of 7 minus k, b to the power, not b, sorry, minus 1 over 4, minus 1 over 4 to the power of k. We just need to know what our k value is. Remember, I told you when you find your k value, everything becomes easy. We just need to know what our k value is. We know we have to get 5 here. 7 minus what gets me 5? 2, right? 7 minus 2 gets me 5. So that means my k value will be how much? If 7 minus k, we know I need 5 in my answer. It's like the answer is going to have 5. Then we know k equals 2. So I can replace everything here with, I can replace all the k's here with 2. So 7, 2, 2x to the power of 7 minus 2, which is 5, right? Times minus 1 over 4 to the power of 2. They want what is the coefficient. So I actually have to solve this. 7c2, let's see, what is it? 7c2, 21. 21 times 2x to the power of 5. 2 to the power of 5, you know, if it's a power, you have distributed it into everything. 2 to the power of 5 is 32. X to the power of 5, right? Minus 1 over 4 squared, if it's a negative square, it becomes positive. And once, so it's, you know, if you have a fraction, you square the numerator and the denominator. Since it's minus squared, it becomes positive, we forget about it. 1 squared is 1, 4 squared is 16. Okay? What can I cancel? I can cancel the 32 and 16, because 32 divided by 16 gets me 2. Okay, so I'm left with 21 times 2x to the power of 5 equals 42x to the power of 5. Okay, so what's the answer? 42. Okay, remember, find your k value. Okay, every question you have like this, write this down. Write down the general term. Write this down. These two. Okay, or like this is the general term in this case for my binomial expansion. This is the general term. Okay, write this down. Okay. Hello, you were gonna do another question. You'll see what I mean. 13. Okay. The third term in ascending powers of x in the expansion of 1 plus 4x to the power of 5. Again, whenever third term, any question they ask, just write down the general term. You're gonna get nck, right? We know it's nck. What's my n? It's 5. So 5ck of 1 plus 4, شو 1 plus قصدي 1 to the power of n minus k times 4x to the power of k. We know our n is equal to 5, right? So instead we put 5. Okay, remember, this is the general term. And I kind of skipped the step where I wrote nck, a to the power of n minus k, b to the power of k. This is the rule, but this is the general term of here. Okay, this is the rule. Just you can write down the rule and then write this down, and just substitute the numbers and write this down. So whatever you want. Okay, once you write down the general term, now we see what is my k value. What do we have in the question? The third term. What did I say we do when I tell you third term? What does it mean? It means my third value. نحن in binomials, we start at 0. So if I were to count, starting from 0, it goes 0, 1, 2, right? So my third term is when k equals how much? 2. Memorize it like this. If they tell you 7th term, يعني k equals 6. Tell you 57th term, يعني k equals 56. Always the number before. Okay, so my k equals 2, since it's the third term. 1 to the power of 5 minus 2, k, which is 2, so 5 minus 2, so 3. It's 1 anyway, so it doesn't really matter. 4x to the power of k, which is 2. You're going to get 5c2, which is, I think, 10 or 5. No, 10 should be 10. Yeah, 10. So 10, 1 to the power of 3 is 1. 4x to the power of 2 is 16x squared. Remember, distribute it everywhere. Okay? What are you going to get? 10 times 16, 160x squared. You see? Same answer. Very easy. Wallah, the questions are very easy, but focus when solving. Okay. What is the coefficient of 1 over x to the power of 4 term? Again, نحن, what do we always do when we have these questions? Write the general term. What's the rule? I'll write the rule for you so it's a bit easier for you to understand. And k, a to the power of n minus k, b to the power of k. This isn't the rule. If you want the full rule, you write sigma k equals 0 n. This is the rule with the sigma. But this is kind of like the general rule. Okay, let's substitute our values. We have n, which is 12. 12k. You write x to the power of 12 minus k, because n is 12. And then minus 1 over x to the power of k. Okay, what did we say we do now? We have to find our k value. What do they want? 1 over x to the power of 4. Okay, so we want x to the power of something. But here, it's x to the power of 4. So you could say maybe x to the power of negative 4. Okay, let's see here. You know, when we're dividing, you subtract the numerator's power by the denominator's power, right? To make it easier, let's not work with the power negative 4. Let's just say power 4. Okay, for now, let's just say power 4. So we need to see two numbers that add up to what? Always the n value. You remember the powers always add up to the n value. So two numbers that add up to 12, but when you subtract them, we get 4. What are they? I'm going to give you them. 8 plus 4 is 12, and 8 minus 4 is 4. So what are my two numbers? 8 and 4. Okay, طب here's the trick. Which one gets 8? Which one gets 4? This one or this one? Let's see. We said it's 1 over x to the power 4. What is 1 over x to the power 4? That means the denominator was bigger, right? That means my denominator was bigger, because my answer is in the denominator. Okay, so since my denominator is bigger, who's going to get the 8? It's going to be this one here. Who's going to get the 4? It's going to be this one here. Okay, so now I know that my k value is equal to 8, not 4. Why not 4? Because the 8 went to the second term, right? We know that this term is the k. The power of this term is k. So if I know that the power of this term is 8, that means k is going to be equal to 8. Okay, so k equals 8. Can I solve? Yes, I can solve. 12c8 equals x to the power of 12 minus 8, which is 4, times 1 over x minus 1 over x to the power of k equals 8. Okay, now 12c8, calculator, 12c8, 495. The answer is 495, but let me just continue the expansion so you can understand. X to the power 4 minus 1 to an even power. Remember, if it's an even power, it becomes positive. Let's forget about this. 1 to the power of 8 is just 1. X to the power of 8 is x to the power of 8. Okay, this times this gets me x to the power of 4 over x to the power of 8, right? So when you minus, you get 4 minus 8. It's x to the power of negative 4. And you know, when you have a negative power, it's the same as saying 1 over x to the power of 4. Again, this is all grade 8 math. Okay, the power rule. It was in grade 8. Okay, when you have 2 to the power of negative 2, it's written as 1 over 2 to the power of 2, which is 1 over 4. Okay, this is just like a reminder of when you have a negative power, when you take it to the denominator, it becomes positive. Okay, so you realize that my answer now has 1 over x to the power 4. We can figure out about this 495. So what's my coefficient? 495. Okay, 15. It ain't loading. Don't do this to me, akhi. Okay, 15. Then you said constant term. Okay, what is the constant term? And I'm gonna give you a rule. Okay, whenever you see constant term, okay, what's the first thing we do as usual? Write down the general term, right? N, C, K, whatever, a to the power of n minus k, b to the power of k. We wrote it down. Okay, let's substitute everything. N is 12, 12ck, a to the power of 12 minus k, b to the power of k. Sorry, my a and b, I didn't substitute them, my fault. A to the power of, let me write it again. A, b, k, whatever, 12k, a is 2x in this case, 12 minus k, and then b is minus 1 over 2x. Okay, to the power of k. Okay, now we need to figure out our k value. And I'm going to give you a rule, and it works anytime you see them saying constant term. Okay, if you see them saying constant term, k equals n over 2. Okay, this is the rule. Okay, I'm going to tell you from now. K equals n over 2. So since I know k equals n over 2, we know our n is 12. So k equals 12 over 2, which is 6. Okay, so you can just substitute now k with 6. 12 c6, 2x to the power of 12 minus 6, which is 6, times minus 1 over 2x to the power of 6. Okay, start doing your thing. Calculator, 12c6, 924. And without having to solve, this minus becomes positive because it's an even power. Okay, and it's 1, so we don't really care. But this 2x to the power of 6 will cancel with this. Once you substitute this, it's going to come 2x to the power of 6, right? And this minus 1 to the power of 6. This 2x to the power of 6 will cancel with this, and this is just minus 1 to the power of 6, which is just 1. So we're not left with anything except this 924, because these cancel with each other. Okay, so your answer will be 924. هلا I paused the recording now because I just figured out, I remembered, there's a rule you can use for the other questions when you want to find out what k is. And in my opinion, it's way easier than having to do trial and error and see what plus this does this. So let me solve this question and I'll get back to the previous two questions, okay? In the expansion of p plus q to the power of n, in the setting power, okay, which is true? The first term is p to the power of n. Remember? Yes, the first term is p to the power of n, and the last term would be what? Q to the power of n. Is it this? No. Is this? No. The first term is not that. We said the first term is p to the n. The last term is pq? No. We said the last term is p to the power of n. Okay. The fourth term is when k equals 3. Is that true? Yes. Remember that the fourth term is when k equals 3. Okay, not when k equals 4, when k equals 3. So is it this? أكيد لا. Okay. Back to here, question 14. Okay. Whenever you're faced with these questions, remember we said always write down the general term. The general term was 12ck x to the power of 12 minus k minus 1 over x to the k. Okay, remember we write this down, right? And then we wanted to see what plus something equals 12, and then subtract gets me this 4, whatever. Okay, I'm gonna give you a rule, okay? This is how you can find out what k is. You write down n minus 2k equals p, okay? P. What is p? It's the final power you want. If it's in the denominator, take it up and make your final power as negative, okay? So in this case, what's my n? 12 minus 2k equals, what's my final power? Minus 4. Okay, take 12 to the other side. Minus 2k equals minus 16. K equals 8. And فعلا, was our k equal 8? Yes, it was. K was 8. If k equals 8, then what is this power going to be? 12 minus 8? 4. 4 plus 8, is it 12? Yes. Is 4 minus 8 minus 4? Yes. So, isn't that just another easy way that you can use? Yes. Does this work with every question? Yes, except the constant term question. The constant term was n equals, so the k equals n over 2. Okay, that's for the constant term. And other than constant term, this will work. Okay, for these questions here. So let's go back command to question 13. I think 15. It was here, yeah? No, not third term. Third term, we said it was easy. You just take k equals 2. Here, yeah. What's the coefficient of the x5 term? Okay, well, is that just, was it just that question? Yeah, it was. Oh, shit. Okay, 14. Yeah, it was just this question where you actually have to divide something by something. Okay, I hope you got that. Remember, n minus 2k equals power, final power. And then here it was n else the k equals n over 2. هلا we have 5, 6, 7, and 10. These you're gonna need a new rule. Okay, again, a plus b to the power of n. Okay, let's say I write it as 1 plus x to the power of 5. Isn't this, let's expand it. You're gonna get 1 to the power of 5 plus 5c1, 1 to the power of 4, x to the power of 1, right? We're just expanding. 5c2, 1 to the power of 3, x to the power of 2, and so on and so forth. Or you know, let me expand it fully. That would actually help you get that point. Then 5c3, 1 to the power of 2, x to the power of 3, plus 5c4, 1, x to the power of 4, plus 5c0, x to the power of 5. Don't you realize that don't you realize that I have 1 in every thing? So wouldn't it just be easier to say 1 plus x to the power, okay, like, you know, before I get there, can't we just cancel the 1? Because 1 times anything is equal to the same thing, right? So we can just cancel the 1. So I can pretty much it's just 5c5, not 5c0. I can just pretty much get rid of the 1 from my whole equation, right? Except for over here, because this is 1 without being multiplied by anything. It's 1 on its own, okay? So 1 plus x to the power of n is equal to, okay, again, sum, it starts at k equals 0, okay, up until n, again, 1 to the power of n minus k, right, times x to the power of k, صح? So it will always be 1 to the power of n plus goes x, 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 x. There's a condition for this rule, okay? The condition is that, well, actually, you know what? Let me make sure about the rule because I'm not pretty sure. Yeah, okay, okay. I just made sure about the rule. The rule I just gave you now is correct, okay? Except there's another rule, okay? This is the actual like new rule I want to show you. The one thing, it just helps. It's not like a rule. It's just something you can remember to make it easier to solve. Like if you see, it makes it easy. Like so, for example, you just see 1 plus x to the power of 5. Quickly, just write 1 to the power of 5. You don't continue writing the ones. That's just something you can remember. But this now, the rule I'm about to give you is something very important. 1 plus x to the power of n equals sigma, again, k equals 0, up until infinity. Okay, not up until n, up until infinity, of a to the power of n minus k, b to the power of k. Okay. Okay, and you have the nck thing. Okay. So what does this mean? Okay, and there's this condition, sorry, for this rule for absolute value of x less than 1. Like whenever you see, like for example here, for absolute value of x less than 1, you're gonna apply this rule. Basically, it's the same rule. Okay, k will keep on increasing by 1. So it's gonna be like, let's say, 1, it starts at 0, then 1, then 2, then 3, then 4, then 5. But up until infinity means just it keeps on increasing until it ends. But if it never ends, how am I gonna have a final answer? Man, look, they're gonna give you up until, like, see, up until coefficient x to the power 4. Okay, so here's what you're gonna do. Why do we use this rule? We use this rule when we have usually different n's. What do I mean? When n is, it's rational. Okay, for example, what's 1 plus x to the power of negative 2? Someone's gonna come and tell me, he's gonna tell me, oh, okay, k equals 0, up until negative 2, and you put negative 2 ck, a to the power of negative 2 minus k, b to the power of k. And then he's gonna be like, okay, I'm gonna tell him, okay, solve. He's gonna say, okay, negative 2 c0 is going to be 1 to the power of negative 2, okay, plus, sorry, just 1. Yeah, actually, yeah, 1 to the power of negative 2, sorry. Okay, plus negative 2 C1, and then blah, 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 and then negative 2 C2, and blah, 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 negative 2 C3. So I'm going to tell him, okay, stop. When do you finish? Do you guys realize, Anna, if I keep on adding 1, will I ever reach negative 2? I won't. So that's why they're like, oh shit, okay, we actually need to find out a rule. So they're like, okay, if you have a negative number, it's not gonna finish, it's never gonna reach n. So what we're gonna do, we're actually gonna change that n, we're gonna put infinity. Okay, so we put this infinity over here. Okay, now we have this infinity, and we can just solve normally. Okay, for example, here, you can be like, oh shit, طب وليد, it's a positive power, bro. Why you telling me all this? Okay, حبيبي, بس نحنا when we did a plus b to the power of n, okay, was n in the denominator? Was all of this in the denominator? Was it? It was never in the denominator. So this is why we have to take it up into the numerator. Okay, so let's take this up to the numerator. What happens when you take this up to the numerator? It becomes 1 plus x to the power of negative 4 over 1. Okay, whatever. هلا you want to expand this negative 4. How would you expand it? Let's see. We're going to use the same rule. Sigma k equals 0 up until infinity. N ck a to the power of n minus k, b to the power of k. Okay, let's start. We start at k equals 0, right? So it's going to be negative 4 c0 a to the power of negative 4, right? In this case, a is 1. So let's just say 1 to the power of negative 4. Okay, plus negative 4 c1 1 to the power of negative 4 minus 1, which is negative 5, صح? Because like it's a to the power of n minus k, so negative 4 minus 1 is negative 5. Then x to the power of 1 plus negative 4 c2, okay, 1 to the power of 4 minus 4 minus 2, which is minus 6, x to the power of k, so 2. We're going to continue all this, but نحن what do we care about? We care about the x to the power of 4. So we obviously know x to the power of 4, يعني x is following the k power in this case, right? Because it's x to the power of k. Remember, write down your general term. K equals 0, infinity. N in this case is negative 4, so negative 4 ck. This is my general term, I'm writing it down. A to the power of negative 4 minus k. B to, not A, I was the 1. 1 to the power of negative 4 minus k. And then x to the power of k. Like I told you guys, you can just take this one outside, and we can actually rewrite all this formula as 1 plus, okay? Yeah, I think 1 plus will, yeah, if I just open the rule, okay, whenever you have this 1 plus x to the power of negative whatever, the rule is sum k equals 0 to infinity, and it's just x to the power of k. Okay, remember why? Because we can just get rid of the 1. If you have this 1 and keep on multiplying by x, what's the point, right? There's no point. So you can just get rid of this 1 over here, because 1 to the power of anything is just 1. Okay, it just makes all this solving way easier. Okay, so you're just gonna have this. How easy is it just to have this? So whenever you have 1 plus x, you can just use this rule directly. Okay, and you're gonna keep on going, like we said here, minus 4c0 of nothing, because minus 4c0, anything c0 is 1. Okay, plus minus 4c1, anything c1 is minus 4. Minus 4 what? X, right? Plus minus 4c2, whatever it is, blah, 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 x squared. Okay, then minus 4c3, I'm gonna write it as minus 4c2. Okay, minus 4c3, x takes what? The power of the k, right? So x to the power of 3, plus minus 4c4, x to the power of 4. Oh, we finally reached our x to the power of 4. Immediately, you can see, since they said absolute value x less than 1, we know, since they said this, we know sigma k equals 0, infinity, x to the power of k. Okay, so since they want x to the power of 4, that means k equals 4. Okay, that means k equals 4, صح? So I'm gonna do The same rule. Oh, sorry, it was NCK, come on. You should have NCK. Okay. The same rule. Negative 4 is my n because we took it up, right? So it becomes 1 plus x to the power of negative 4. You can't solve it with the denominator. So it becomes negative 4 c4 x to the power 4. How do I solve this? Very good question. Go on the calculator. That's what the first person will tell me. Negative 4 c4. Negative 4 c4. Math error. Exactly. Why? Because you can't have a negative factorial. You know, combinations, you need factorial. Can you have negative factorial? No. Someone will say, okay, top take the negative outside. Top, that doesn't work. You can't do that with combinations. Okay, so here's what you do. How do you find a combination with a negative 4? Okay, you're going to write it in the term of n, k. Okay? I'm going to write it for you like this. It's going to be n minus 1, n minus 2, n minus whatever 3, it goes n minus whatever, blah, 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 blah. Okay, over r factorial. It's similar to our first formula. Remember the first formula of NCR? It was n factorial over r factorial, n minus r factorial. Remember this? See, this is a bit similar, but like, what's happening now? Let me show you. This n minus 1, n minus 2, you're going to keep on subtracting by 1 until you have the same amount of terms as your r. Since my r is 4, that means I want 4 terms. So here I'm going to stop. I'm going to stop at the minus 3. I'm not going to write n minus 4. No. Okay? I'm not going to write that. Okay? I'm going to stop. I have 4 terms. خلاص. So, how will I do this? How will I rewrite this now? My n is minus 4. So I'm going to write minus 4. Then I'm going to... Oh, it's over 4 factorial. That's the first thing you should write. Put your 4 factorial down. Right? What's my numerator? This is the only tricky part students get confused in. Minus 4. Then you start by subtracting by 1. Okay. You subtract by 2. How many terms do I have? I have 1, 2, 3. How many terms am I supposed to have? 4 terms. So I do one more. Minus 4, minus 3. Okay. هلا, can I solve? Yes, I can. This is the rule. 4 negatives make what? Positive. Cancel, 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 cancel. Okay. Actually, you know what? Before you cancel, solve it, actually. Yeah, solve it, solve it. Don't ignore it. You have minus 4, minus 4, minus 1, minus 5, minus 4, minus 2, minus 6, minus 4, minus 3, minus 7, over 4 factorial. Now, the 4 negatives make a positive. So you get 4 times 5 times 6 times 7. Let me put this to the side. You get 4 times 5 times 6 times 7 over 1 times 2 times 3 times 4. 4 with 4. 2 times 3 is 6. So 6 with 6. You're going to be left with 1 denominator. So it doesn't matter. Your answer is 5 times 7, 35. Okay? Was it a confusing question? 100% yes. How do I explain it one more time in an easier way? Okay? Whenever you see absolute value x less than 1, you should immediately say that's the infinity rule. Same rule, just up to infinity. Okay? And ck. But what? There's no... You forget about the first term, right? So we forget about the 1. We just write x to the power of k. Okay. We saw that. We wrote out our rule. We remember our rule now. Okay. This here. What do I do with it? Can I keep it down? No, I have to take it up. So 1 plus x to the minus 4. So what's my n? Negative 4. Okay. هنا شو بدنا منا? Remember, the first thing you want to know is your k value, right? We want to know our k value. That's the thing that matters here. And we can quickly get it. We can, okay, what, you want the n? Okay, minus 4 ck x to the power of k. You have sigma k equals 0, infinity. Okay. You wrote your n. What did you benefit? You still need to find the k. So you go to the question, what do they want? Coefficient of x to the power of 4. What do they always say the power of x is? The power of x is k. So that means if the power of x in this case is 4, that means my k is 4. So now I know k equals 4. So what do? I solve. Sigma, okay, starts at k equals 0 up until infinity. Okay, but we don't care about the sigma. We can just immediately write minus 4 Okay, forget about the sigma. We don't care about it now. Sigma is if you're expanding it fully. نحن we only care about one term, it's the x to the power 4 term. So minus 4, c, how much is my k? 4. So minus 4 c4, x to the power of 4. هنا what do they care about? They care about the coefficient. So I need to find minus 4 c4. How do you find a negative factorial? What's the first thing you write? You write the denominator, 4 factorial, right? Now up, we want to put negative 4 factorial, but we can't write negative factorial, so what do? Negative 4. Then you keep on subtracting by 1. Negative 4 minus 1. Negative 4 minus 2. Until how many terms do I have in my numerator? I should have the same amount of terms in the numerator than the number I have in the denominator. So since my number in the denominator is 4 factorial, I should have 4 terms up. This is my first, this is my second, this is my third. Do I have 4 terms? No, not yet. So I have to add one more. Subtraction. Okay. So you get minus 4, minus 5, minus 4, minus 5, minus 6, minus 7 over 4 factorial. Positive, 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 positive. 4 factorial is what? 1 times 2 times 3 times 4. 4 with 4. 6 with 2 times 3 is the same as 6, so you can cancel them. You're going to be left with 1 down, so that doesn't matter. 5 times 7, 35. So see, I managed to explain that in less than a minute. Okay? You just need to know the formula. And I'm taking my time because I need the formula. How much is this? 56 minutes. Okay. 5, 6, 7. These questions, I think they will take some time. Okay? Let's see. Here, do I think they will bring this? I don't know. I said, don't take my word for it. Okay? You still have to do it. They want us, okay, they're being nice. So they're telling us to expand until x cubed. Okay, so it doesn't really matter. What's the first thing we can see here? The first thing we can see here is that we have something in the denominator. What do we tell those people in the denominator? We have to tell them, get up, right? So we're going to take it, x plus 4, 1 minus x to the power of negative 2. Okay, so this x plus 4, it's nice. It doesn't have a power. It's chill. But this here, it has a power. So we have to expand it. What's its power? It's negative. Okay, and what did we realize here? It has 1. Okay, it has 1 and it has a negative power. So what rule do we use when you have a negative power? We use the rule sigma k equals 0 up until what? Infinity. Whenever you see a negative power, you must know you're using this rule. And ck x to the power of k. Right? Forget about the 1, because 1 times x is what is x. 1 times x squared is x squared. So it doesn't matter. Okay. Let's start expanding this now. What do we know? We know that we're going to expand until x cubed, right? So let's continue expanding until x cubed, right? So let's start expanding. What's our n? N is negative 2. So negative 2 ck x to the power of k sigma k equals 0 infinity. Here, they didn't ask us about specific term. They want the full thing. They want the full expansion. So what do? We have to start. Yalla. Negative 2, we start at 0. Negative 2 c0, أكيد. It's going to be x to the power of 0. And immediately, anything c0, anything to the power of 0, we just write 1. Okay, plus, let's continue. Negative 2 c1, x to the power of 1. Negative 2 c2, x to the power of k2, plus negative 2 c3, x to the power of 3. Are we done here? Yes, we're done. We reached the power 3. Okay, let me give you a few tricks. Negative 2, anything c1 is the same as that number. So negative 2 c1 is just negative 2. So negative 2x. Plus negative 2 c2. We actually have to solve this, right? So let's see. Negative 2 c2, how do we do it? We start. What do you do when you have negative factorial? You start with the denominator factorial first. So 2 factorial, write it down. What do we write? Our number. We have to continue subtracting until we have how many terms in this case? 2 terms. So we only need to subtract once, right? See, we already found 2 terms. This term, first term, this is the second term. Okay? This is easy. Quickly. You don't need to like write a lot. Okay, so I found it. This becomes negative 2, negative 3 over 2 factorial. 2 factorial is 1 times 2, so it's just 2. Negative 2 times negative 3 is negative 6 over 2. As the issue, it's positive 6 over 2, which is 3. So 3x squared. Hella negative 2c3. Same thing. What do we start with? The bottom factorial. 3 factorial. What do we start with then, right? Negative 2. Now we have to keep on subtracting until I have how many terms? 3 terms. I already have 1 term. Yellow. Second term. Negative 2 minus 1. Third term. Okay. Hella, let's solve. It comes negative 2, negative 3, negative 4 over 3 factorial. 3 factorial is 1 times 2 times 3. Okay. let's substitute let's simplify this a bit. This this yeah, let's just multiply it all out. It doesn't matter. These are easy numbers. Negative 2 times negative 3, 6. 6 times negative 4, negative 24. So negative 24 over 1 times 2 times 3, 2 times 3, 6. You get negative 4. So negative 4 x cubed. Did we expand it up until x cubed? Yes. Are we done? No, we're not done. Why? Because we forgot about this x plus 4. So we're going to take this whole thing and multiply it by what? X plus 4. This is a bit easier. So you're just going to take each thing and multiply it there. So I'm going to erase this working here on the side because I need some space. So let's start. 1 times x. X. 1 times 4. 4. Minus 2x times x. Minus 2x squared. Minus 2x times 4. Minus 8x. 3x squared times x. 3x cubed. Shit, hold on. 3x cubed. 3x squared times 4. 12x squared. Minus 4x cubed times x. Minus 4x to the 4. Minus 4x cubed times 4. Minus 16x cubed. Okay. I think I made a mistake. Oh, shit. I realize now I forgot to do my x. Instead of writing x, it should be negative x. I didn't realize that. Please be careful when solving. You would have gotten the question wrong if you did the same thing as me. Okay? It's negative x. Okay, so negative here, and negative here as well. Okay, so this would have been negative 2x. Sorry, this is negative 2 times negative x. It should be plus, right? Then this negative square, it becomes positive, so we don't change that. But here, this negative x cubed would become negative x cubed, but you have negative 4 times that negative x cubed, so it would be plus. Okay, so let's change our values here. Let me repeat. This 1 times x is 1x, 1 times 4 is 4, 2x times x is yeah, this is plus, it's plus now. So it should be plus 2x squared, and 2x times 4 should be plus 8x. Then 3x squared times x, 3x cubed. Okay, 3x squared times 4, 12x squared. Okay, then plus 4x cubed times x is 4x to the power 4 plus. Yeah, it should be plus. Then 4x to the cube times 4, it should be plus 16x cubed. Okay, so just pay attention to that. Hello, we're done multiplying. You combine like terms. Let's start with our highest term. Or no, they want to start with the lowest term. Let's start with our constant value. Is there any other constant? No. So we cancel 4. Then start with our x's. X here. We have 8x. Nothing else. X plus 8x is 9x. Done. هلا بالsquare x squared 2x squared 12x squared. Add them 2 plus 12 14. هلا بالcubes 3x cubed 16x cubed. Add them 3 plus 16 19 x cubed. You're left with the power 4, but they're not asking about it. So you see our answers are all the same. هلا question 6. Okay, here, okay, it's the same thing. Okay, they gave you the absolute value ونفس الشيء and they expand as far as x cubed. Okay, it's the same thing, but, okay, there's a big but here. It's 1 over 2 as your exponent instead of a negative number. Is it the same rule? Exact same rule. Okay, exact same rule. Okay, what do we say? Since it's 1 here, we don't write, sorry, since it's 1 and it's the absolute value thing, what rule do we use? Sigma k equals 0 up until infinity. Okay, nck x to the power of k. صح? So let's start substituting. Starts at, we want to reach x cube, right? So let's reach x cube. We're going to go up until k equals 3, obviously, since we want cube. So we're going to start nck. So 1 over 2 is my n, صح? 1 over 2. 1 over 2 c0 plus 1 over 2 c1 plus 1 over 2 c, how much? 2 plus 1 over 2 c3. This is where we start. Oh shit, and I forgot to put the x part. Yeah, سكران يا عمي. 1, so x is going to be power 1. Here it's x to 0, that's why I didn't write it. Here 1 over 2 c2 x to the power of 2. Here it's 1 over 2 c3 x to the power of 3. هلا can we solve? Yes. That's what do we need? شو x قصدي minus 4. My x is minus 4x. Minus 4x minus 4 minus 4. Okay. Sorry, huh? I forget sometimes. Okay. It's 1 minus 4. I should have written it at the start. 1 minus 4x to the power of half. Okay, I should have written this. Anyway, so you have this. We just expand. Anything c0 is 1. Anything c1 is that same thing. So 1 over 2 times minus 4x. Okay, let's simplify. We simplify later. Okay, then 1 over 2 c2. Again, can you find 1 over 2 is 0.5. Can you find 0.5 factorial? No. So what rule do we use? The same rule for the negative factorial. What's the first thing you write? 2 factorial. So write it down. Then what do you write? 1 over 2. Then what do? You keep on subtracting until you have how many terms? In this case, 2 terms. So 1 over 2 minus 1. Do we have 2 terms? Yes, we do, right? So what is this going to be equal to? Don't waste your time. Just go on your calculator. Okay, go on your calculator fast. Put a fraction, then put 1 over 2 up. Okay, then put brackets 1 over 2 minus 1. Okay, over 2 factorial. Okay, don't waste your time and solve. Just put it in a calculator. Hatta with the negative factors, you can just put it in a calculator, but you have to write it like this. You have to put negative 2 minus 1, negative 2 minus 2. You have to write it like that. Okay, so you're gonna get here minus 1 over 8. So minus 1 over 8 minus 4x squared. Minus 4x squared is equal to 16x squared, صح? Because why 16x squared? Because minus 4 squared is 16, becomes positive because it's an even exponent. Then x squared is just x squared. Okay, plus half c3. It's just the same thing, half c3. You first, what do you write down? You write down the factorial down. Then up we write 1 over 2 again. Then 1 over 2 minus 1. But it's 3 terms, right? We need 3 terms. So do we continue? Yes, we do. 1 over 2 minus now 2. Again, what do we do? Put it in our calculator. Let's not erase this. We already have it all written down. So let's just put 1 over 2 minus 2. Close the bracket. And now we want 3 factorial. You get 1 over 16. Okay. 1 over 16. We write it here. Then minus 4x cubed. Minus 4 cubed, since it's an odd power, it doesn't matter. It can stay negative. Minus 4 cubed is minus 64. And then, sorry, why did I close it? And then x cubed is just x cubed. Okay, let's start simplifying. Half times negative 4 is negative 2x. We have this one here. 1 minus 2x. 16 divided by 8 is 2. And minus 1 times 2 is minus 2x squared. We're done here. We're done here. We're done here. 64 divided by 16 is 4. But it's negative 64. So negative 64 divided by 16 is negative 4x cubed. Isn't this just the same answer? Yes. I think خلاص you're starting to get the hang of it by now. I mean, we're 1 hour, more than 1 hour into recording. If you don't get the hang of it by now, I don't know what to tell you والله. بس كمان أنا عيبت a lot this recording. Well, I just tried. I'm trying my best to give you as much details and as much information as possible. هلا part B is the part most students get confused in. Okay, I'm gonna erase all of this. Okay, and the only thing that matters to me is this part here. By substituting x equals 10 to the negative 2, 10 يعني 0.0. They're saying to substitute this to find the square root of 96. Okay. Before we do all of this, I want to remind you 4 to the power of 1 over 2 is equal to 2. Walid, what did you just do? Okay, here. Whenever you have a fraction as a power, you have something in radicals, we have something called the index and the thing under it, okay? The index is always the denominator in the fraction. And the power up is the power that goes inside the radical. For example, 3 to the power of 4 over 3. What is this equal to? The number down is your radical. The number inside goes inside as your power. So this is the same as saying this. Okay? So whenever you see 1 over 2 as your power, so like 4 to the power of 1 over 2, it's the same as saying the square root of 4 to the power of 1, right? When 2 is your index, any square root, any radical. Okay? So what I'm trying to say is that this 1 over 2 means radical, square root of 1 minus 4x. It's the same thing. Okay? طيب, they're saying substitute x as 0.0. Let's substitute. Okay, square root of 1 minus 0.01 times 4. صح? 4 times 0.0, whatever. You're gonna get square root of 0.96. Okay. Did they say square root of 0.96 or square root of 96? Square root of 96, right? So what do you have to do to get from 0.96 to 96? We have to what? Times 100, right? So what do I do? Here's what you do. You're going to rewrite, since we have to multiply by 100, you have to multiply by 100, we're going to rewrite the square root as the square root of 0.96 what? Times 100. Okay? طيب. Are we going to multiply 0.96 times 100? No. Here's what you're going to do. What do we know what the square root of 100 is? Yes, we do. It's 10. So you can just take the 10 outside and you'll be left with the square root of 0.96. Isn't the square root of 0.96, is it the same as 0.96 to the power of 1 over 2? Yes. And didn't we just expand this up here? We did. So let me repeat what I just did. This is the same as 1 minus 4x in the square root. Okay? Since we said we have to multiply our 1 minus 4x, our whatever, 0.96, we said I have to multiply it by 100. So we're going to rewrite the square root of 1 minus 4x. We're going to say 100 times 1 minus 4x. And instead of multiplying the 100, actually multiplying it, we can just square root it and take it out. 10 radical 1 minus 4x. Didn't we expand? We already expanded this 1 minus 4x earlier, and we got this, right? They're saying also use the expansion used in part A. So can't we just say it's 10 times 1 minus 2, 1 minus 2x minus 2x squared minus 4x cubed, right? Since we already, this is the same as this, but the 10 is outside this time. And what did they say to substitute x by? 10 to the power of negative 2. So 10, 1 minus 2 times 0.01 minus 2 times 0.01 squared minus 4 times 0.01 cube, close the bracket. Okay, put this in a calculator. You're going to get this. They said to 6 significant figures. You're going to get this. Okay, so what are students going to get mixed up in here? Here's what you do. You need to find out what you have to multiply your original one to get the new one. How do you find out? You do this. Follow my steps exactly. You substitute x. Okay, you substitute x. This is the same as saying radical. Let's just say radical. You substitute x. You're going to get 1 minus 4 times 0.01. Substitute, you're going to get radical 0.96. Okay, what do you do after you substitute? You want to see what's the difference between your number here and the number there. What is it? This is square root of 96. What's the difference between this? 100. So now you know that what you have to multiply by. So what do you do after you find the number you multiply by? You just multiply your actual equation by it. So this 1 minus 4x to the power of 1 over 2, we're going to change it to 100 times 1 minus 4x to the power of 1 over 2. Okay? And what does this become? Square root of 100 times 1 minus 4x. Square root, and you take the 100 out, becomes 10 radical 1 minus 4x. Then expand this like we did here, and substitute 10 to the negative 2, which is 0.01. Okay, and you get this to 6 significant figures. I won't do to my calculator. Okay, question 7. Last one. Expand this. Okay. نحنا, we know that the radical can be rewritten as to the power of half, right? To the power of 1 over 2. Okay, let's write this as power of 1 over 2. Okay, some people now, they're going to say, oh, you have the denominator, just like substitute, use the rule, k equals 0, okay, up until infinity, okay, n, c, k, x, whatever. Okay, two things. أول شيء, we said for the condition of this rule, we have to have 1. Do we have 1? Guys, do we have 1? We don't have 1. Can we take this 9 outside? Yes, we can. How do we take the 9 outside? We divide by 9, right? Let's take 9 outside. It's going to become 1 over 9 outside becomes 1 plus x squared over 9. صح? The power of 1 over 2, don't forget. Okay. Remember, this 9 is part of this. It's still under the 1 over 2. It still falls under the power of 1 over 2. Okay. طيب. Now, نحنا, to make things easier, I'm going to change this 9 into a 3 and take it outside of this 1 over 2. Because, you know, this radical means, this 1 over 2 means radical. And radical 9 is 3. So I took the 3 out and I have 1 plus x squared over 9 to the power of 1 over 2. I don't like writing it like this. So I simplified the 9, radical 9, 3. Remember, it's all still under 1. Okay, so Walid, خلاص, now we can apply the formula. No, you can't. Why can't you? Let me tell you why. Because it's in the denominator. Did we say you can apply to in the denominator? No. What do we have to do? Take it up. Okay, so it's going to become 1 over 3. The 3 stays down. أنا ما دخلني بال 3. Okay, 1 plus x squared over 9 to the power of هلا negative 1 over 2. Okay, they want us to expand it for the first 3 terms. Okay, can we expand that? Yes, we can. Now we have all the conditions met to expand. It's in the numerator, and also 1 is my first number. Okay, can I use this formula? Yes, I can. Let's start. N C0. My n is negative 1 over 2. So negative 1 over 2, C0. And you know, when it's 0, there's no x, you don't write. Plus, negative 1 over 2, C1 of x squared over 9. X squared over 9. Yes. Okay, plus negative 1 C2. Sorry, negative 1 over 2 C2 x squared over 9. وهلا قد ايه بتصير الباور? Here it was power 1. Here it's now power 2. Okay, let's evaluate. Because they only wanted the first 3 terms, so I didn't want to do it all. Negative 1, this is anything C0 is 1. Anything C1 is obviously, anything C1 is itself. Negative 1 over 2. Okay, and then x squared over 9. And then this C2. Negative factorial. How do we do it? We first write the 2 factorial down, and then we write our first term. How many terms do we need? We need 2 terms. So we're going to keep on subtracting until we get 2 terms, minus 1. Okay, do this in a calculator. I think you get minus 1 over 2, minus 3 over 2. I'm not going to bother. I'm actually going to put this in a calculator. Minus 1 over 2. Let me delete this. Okay, go here, change this to minus. Okay, change this to minus as well. Go down, change this to 2 factorial. Okay, you get 3 over 8. Okay, so this is equal to 3 over 8. Let me change this. We're going to put 3 over 8, right? And then x squared squared is x to the power 4. 9 squared is 81. Okay, we're missing something here. What are we missing? Was the question just 1 plus x squared over 9 to the negative half? So the thing we forgot about writing here is that in the exam you can't forget. I don't think they will get this. This is what they will get in the written next week in the periodic. Okay, they will get this question written. Mark my words. Okay, this or something that looks a lot like it. What you forgot to write is this 1 over 3. It's still part of our thing, part of our expansion, right? We're expanding the whole thing. So we have to write 1 over 3 times everything here. Okay, yalla, let's multiply. 1 over 3 times 1, 1 over 3. Let's multiply this first. Minus half, okay. Over 2 over 9, it becomes 18 over 18. Okay, and then minus x squared. Now, 1 over 3 times over 18 gets me 3 times 18, 54. So, minus x squared over 54. Okay, this is just simplifying. So, this simplified with this got me this. Then this times this got me this over here. Then, this here, this 3 can cancel with this 3. With this 8 times this 81 gets me 648. So plus x to the power 4 over 648. Did we get the same answers? Yes, we did. So 354, 648. So I'm going to erase all of this and keep this last part. Okay. هلا they said the condition. Remember, what is the condition? This x whatever. The condition, I wrote it here. It's for absolute value of x less than 1. In this case, absolute value of x has to be less than 1. What's my x here? It's x squared, right? Sorry, no, not x squared. When we took it up, remember when we took it up, you can't take it from here. Remember, we only apply the rule when you take it up. And when we took it up, it was 1 plus x squared over 9 to the power of 1 over 2. Remember? So what's my x? My x here is x squared over 9, right? This is for 1 plus x to the power of n. This absolute value of x has to be less than 1. X is the number you have here. What's the number I have here? X squared over 9. So x squared over 9 has to be less than 1, right? Absolute value. So what am I going to do? Obviously, I'm going to multiply by 9, right? I'm going to multiply by 9. It's going to be x squared less than 9, right? Okay. X squared less than 9. What are you going to do? You're going to take the 9 over here. It's going to become x squared minus 9. Isn't this a quadratic equation, right? What are its roots? X minus 3, x plus 3. And we need to know when is it less than, we need to know like when is it, like when is it between each other, like where it's positive, where it's negative, like kind of that, because we said less than 1. Okay, when you took x squared less than 9, we took the 9 to the left, it became less than 0 because we don't have anything on the right anymore. So we need to know x squared minus 9, when is it less than 0? Okay, let's see. Okay, isn't this a quadratic equation from how we did in grade 10? Yes. Don't we have the roots 3 and negative 3? Yes. Can't we just do f of x table like last year and write our roots 0, 0? In between the roots, it's opposite. So opposite to positive is negative. So when is it less than 0? In between negative 3 and 3. So in between negative 3 and 3. If you have a question that comes like this, okay, where it's in between two things, it's usually if there's no square, like here it had square, but usually if there's no square, it's just in between the positive and negative of this number. So if it was just x over 9, it would be in between minus 9 and 9. Okay, but since we had square, you had to find the square root. Okay, so we're done from this. هلا using the expansion found as far as the term in x to the power 4 in part A. Find radical 1 over 10. Okay, نحن هلا عنا radical 1, forget about the radical, they put it to trick you. Radical 1 is just 1, so they want 1 over radical 10. Okay, and what do I have? I have 1 over radical 9 plus x squared. How do I make this into 10? 9 plus x squared. I have to add 1, 9 plus 1, right? And what? X squared equals 1, so x is 1, right? So I have to substitute x with 1, right? Now I know what I'm going to substitute x with, because I wanted to get 10. Can't I just substitute x with 1 here? They said as far as x to the power 4, right? We can. So it's going to be 1 over 3 minus 1 squared over 54 plus 1 to the power 4 over 648. And you're going to get to 4 decimal places. Because 4 decimal places, 3164, 0.3164. Part D, very easy. In absolute value, so they just want the positive value of the difference between the calculator value of 1 over radical 10 and the approximation that we found here. So what do? We take 0.3164, or you can just put absolute value first. Absolute value, where's absolute? ما في absolute on? Here, hype, shift hype, absolute value, 0.3164 minus 1 over radical 10. Okay, we want it, if you get an answer like this, press shift ing, keep on pressing it until it becomes 10 to the power of 0, like it is here, and they said to 4 decimal places. So you want 4 decimal places, 1, 2, 3, 4 decimal places. It's 7 is a strong number, so it becomes 0.0002. That's your answer. Like this, we're done for today. Thank you so much for watching. Good luck. I hope all of you do well. Thank you so much.